Hey Bulldogs, Chris Bryant, CCIE number 12933 here, and in today's combination video practice exam and tutorial, I'm going to be presenting you with 5 questions on Eigrp and route summarization. And the first question actually involves performing the summarization, so I'd really like you to do that one along with us. If you need to pause the video for a moment, that's great, because as usual we're going to go through the questions pretty quickly, especially today because I want to show you how we arrive at this particular route summary and also how we apply it in Eigrp. I've got a little baby Eigrp network for us on our live Cisco routers here in the pod, so we can also perform this live and see the effects of it. And here is that first question. I want the summary for these 4 networks and the full command to advertise these this summary route via Ethernet 0. And you're assuming an autonomous system number of 100. So we'll be doing that here on a whiteboard in just a moment, and also we'll be doing that live on the equipment. So if you need to pause the video for just a moment to do that summarization, that's fine. Question 2, what is the default setting for variance in Eigrp? And also a little extra credit, everybody likes extra credit. What command will show you that value and the source of any incoming Eigrp routing updates? And let's move on to question 3. Which of these terms describes the use of wildcard masks in Eigrp network statements? Is it required, optional, or unacceptable for one of those 2 reasons? Question 4. Which of these values does Eigrp not use by default in route calculations? And then question 5, of RIP version 1, version 2, OSPF, and Eigrp, match the protocol with the algorithm that it uses for route calculation. And let's head back to question 1 now and take on this summarization. The first thing we've got to do is break that first octet of each address down into a binary string. And I've already done 100 here. I'll bring up actually Notepad since we're right here. I've already broken down 100 for you, and since those 3 addresses all end in zeros for the last 3 octets, we're not going to break those down because we don't need to go that far to do the summarization. We also know what that looks like anyway if it's 0. So 101 then would be 011000101 because we're just adding 1 to that. That should be 102, and that should be 103 because we've got the 64-bit here, the 32, and then the 4, which gives us 100, and then we're just tacking 1 on here, 2 on here, and 3 on here. So if that's our summary, or actually the binary strings representing 100, 101, 102, and 103, how do we get the summary route out of this? All you need to do is, working from left to right, identify the bits that all 4 routes have in common. And going from left to right here, how many bits do they have in common? Can't give you too long to think about it because I don't want to run out of time here. We've got 6. Working from left to right, that's all you're doing. And to get the summary route, all you've got to do is take that value and translate it into decimal. So we know that's got to be 100, right? If we're just adding up the first 6 bits of this 8-bit string, we know that's 100. We already broke it down. So far this might look a little odd if you're new to summarization, because that is the resulting network summary. And you might be thinking, well, that's great, but how can I summarize all 4 of these routes with just this one? Well, you're using that network number, but your mask is going to be different. And let's bring our pad back up here. To get the summary mask, and I'll just actually put it up here and just call it SM. Our summary mask is going to have 1s for those first 6 bits because those are the in common bits. And then after that, they're not in common, so we would put all 0s. And of course, for your last 3 octets, they're going to be all 0s as well. We know that. So you're going to have 1s at the very beginning of your summary mask for every bit that these routes have in common. And then after that, it's all 0s. So if that first octet looks like that, what's the value of it in dotted decimal? What do I need to put in front of this? 252, right. So this is your entire summary. This would be incorrect because that's not giving you the entire thing. You've got to have the summary mass to go along with it. So now that we know what that is, we need to apply it. So I'm going to bring up a pod here where I already have, and I'll verify, I have an Ethernet adjacency between routers 2 and 3 over an Ethernet segment. And in router 2, I am advertising 4 loopback networks into Eigrp, and there are these 4 networks. And I'll show you the config that I came up with for that. And that might look a little odd to you, but that's what I put in. The 172.23.0.0 network is the network connecting the 2 routers. So if we go over to router 3, and I'll just run show IP route Eigrp, we can see all 4 routes. But what we want to do is summarize them so that the advertisement isn't as large. Maybe we can summarize that down to 1 route, because this is in effect what we're doing right now. It's a quick shot from my CCNA study guide where router 2 is advertising these entire 4 routes as part of the routing update. But we just summarize them. So now we've got to put the summarization on the router that's doing the advertising. So oddly enough, we do that at the interface level. We don't go under Eigrp router config and do this. The command is IP summary address, and there's Eigrp. And we're going to put the autonomous system number, which we almost always have to do with anything having to do with Eigrp. Now we're going to put in the address, and then we're going to put in the mask, and then finally we're done. So let's go ahead and do a save there, and let's make sure our adjacency, yeah, that's what I wanted to see. I wanted to get over to router 3 to show you that. A lot of books leave this little important detail out, but when you perform summarization like that and you put it on the interface, you're going to lose your adjacency. See where it said neighbor change and then peer restarted? And what that really meant was a summary was configured on the other side. But you could see this one came up almost immediately. Right after that we got the new adjacency message, but you need to be aware of that, obviously. So let's take a look at that routing table now, and look at that all the way down to that. So now we've summarized it to 1 entry, and I can send pings over to those loopbacks and they're going to come back just fine. And I'll go ahead and ping the last couple here, and then we'll zoom through those last few answers. I'll hit the 10-minute time limit here. So that's how you perform route summarization. Just that simple and straightforward. As long as you know basic binary skills, you'll be fine. So that's the command to do it, and that's the effect. The default variance command value, and let's bring the router back up. You can actually see that with show IP protocols, and this is a great command because you can see you're right here. There's the variance setting. And also it's going to show you where you're getting routes from. So that can be handy in troubleshooting as well. With the network statements, as you saw, my statements on router 2, I didn't use it. It's actually optional. I really recommend in production networks that you do use them, and you'll probably see them in every production network you work in. But for your exam and your studies, you need to keep in mind that that is actually optional. Question 4, since we know that Eigrp does use bandwidth and delay by default, it does not use MTU, load, or reliability. Bandwidth and delay are the default values that Eigrp does use. And then finally here with RIP version 1 and 2, they use Bellman-Ford. OSPF uses the SPF algorithm, which is also known as the Dijkstra algorithm. And finally, our friend that we've been working with here today, Eigrp, uses dual. Thanks for hanging there with me on that. I hope you enjoyed both the practice exams and the tutorial. Make sure to visit our YouTube channel for over 100 additional free videos, and join us now on Twitter as well so you can find out about new ones. Thanks again for watching. I'm Chris Bryant, CCIE number 12933.